Welcome back to section 7.3. So, in the previous lesson, we talked all about the basics of logarithms, what they are, and how to evaluate them. So, now we're going to take a day to investigate what do the graphs look like. Now, you actually already sort of know, because we talked about this being the opposite of an exponent. Okay, so those exponential functions we did back in the first half of chapter 7, that looked like this, following that red line. Well, now our logs are the exact inverse of that. So they're going to follow the exact opposite pattern, okay? And note, just like when we did inverses back in chapter 6, note that they are exact reflections of each other across that line y equals x. So again, you basically know the shape. It's just the exact reverse of how we did it in the first half of chapter 7. Now, the big key to this is realizing how to rewrite that log as an exponential function, okay? Because again, you guys are probably much happier thinking about exponents than you are thinking about logarithms. So, if I give you this and tell you to graph it, y equals log base 3 of x. Remember Mr. Loopy from the previous notes. So what I'm going to do is I'm going to take 3 to the y equals x. Okay, and I do already have that written there as well. So whenever I give you a logarithm to graph, you need to rearrange it for me, okay? You need to turn it into its exponential form, okay? Now, the interesting thing about this, the thing that's going to be really backwards and you have to be very careful about, is we're used to picking x's and then calculating y. And what we're actually doing here is the exact reverse, okay? Right now, we are going to be picking y values, and that's going to be computing x, because x is 3 to the y. So it's interesting, because again, it's the exact opposite, which also means you have to be very careful that you're doing it right, because it is going to be a little bit odd for you to have to solve problems this way. But once I rearrange it to get 3 to the y equals x, now I start picking y values. So these are typically the values that I would recommend you pick. Because outside of that window, most likely you're not going to be able to see the points anymore. They're going to be off your graph or too little to graph, okay? So let's take a look at this. I plug in -1. So 3 to the -1 is 0.33. 3 to the 0, well, anything to the 0 power is going to be 1. 3 to the first power is 3. 3 to the second power is 9. So I generate my table just like always, except I'm just doing it in the reverse. I pick y values to calculate the x values. And now I'm going to go and draw these. So looking at this, I have an x value of 0.33, -1. So that's going to put me right there. 1, 0, 3, 1, and 9, 2. All right, so there's the points that I have. Now, there was a special feature when we were graphing exponential ones, okay? A feature I introduced to you called the asymptote. Now, since this is an exact mirror image, there is going to be an asymptote, but it's going to be different. For the exponentials, remember, it was sitting horizontally. Now, this time, it's going to be a vertical asymptote, because remember, when you take the inverse, it flips everything. So now the asymptote isn't going to be horizontal. The asymptote is going to be vertical. All right, and just like with exponentials, when there's no shifting, it's going to be sitting at 0, okay? When there's shifting, which we're going to get to, then we'll talk. So once I have that, I don't have any shifting or translating, anything like that. So I'm going to connect my points. And remember, the point of the asymptote is I'm trailing off forever, getting infinitely closer to it, but never actually touching it. So that's the basis of the graphing, okay? But now let's talk about the features, because just like with exponentials, there were features we were looking for that I asked you to calculate for me. So this time, let's start with the range, okay? Because with exponentials, domain was the easy thing, but this is the inverse, this is the exact opposite. So now it's actually the range that's easy. It was the y values we could pick anything for, okay? So for these logarithms, it's the range this time that's all real numbers and the domain that we have to be careful about. The asymptote is sitting at x equals 0. There was no shifting. So now let's look at this idea that, remember, we always compare to the asymptote, okay? And this time, again, it's domain because we had to calculate those x's. So, and every x is greater than 0, okay? And remember, strictly greater than 0. It can't actually be a 0 because then it'd be on that line, and we can't have that. So, again, very similar to what you've done before, but just a lot of reversals as we're graphing these. Okay, so we realize this first one probably a little bit confusing. Let's move on, do some more to help you get accustomed to this way of thinking. Okay, so looking at this next one, y equals log base 4 of x. So remember, the very first thing is I need to rearrange this. I need to rewrite this. So 4 to the y equals that x. It's so utterly important that you can rearrange that. You can write it in its exponential form. Okay, because now this x right here is actually calculating those 4 to the y's. That's how I'm finding the x's. Now I'm inputting y's to find x. Okay, so let's do it. Let's start at -1. So 4 to the -1 power is 1/4 or 0.25. 4 to the 0 power, well, anything to the 0 power is 1. 4 to the first power, anything to the first power is itself. 4 to the second is 16. Well, now you're getting too big, okay? So let's plot some of those points. So 0.25, -1, puts me there-ish. 1, 0, and 4, 1. And those are the only ones that I can actually plot. All right, now the asymptote. Well, again, there's no shifting in this one, so my asymptote is going to be sitting at 0. The only thing you need to remember is this time, because it's the inverse of the exponent, we have a vertical one instead of a horizontal one, okay? And because it hasn't shifted, it really is just sitting at 0. So now I'm ready. I can connect my points. Just like that. All right, now here again, let's start with the range. The range is an easy one because I could pick any y value that I wanted. Okay, so in picking any y value that I wanted, that's what makes it all real numbers. I had no limitations on what I could pick. Now, for the domain, remember, whenever we're dealing with an asymptote, we compare the domain to that asymptote. And in this case, once again, it's everything greater than that 0, but it can't actually be 0. So there's the fundamentals. There's the basics of how to graph these things. So let's start diving into what can happen when we start putting in transformations to these. Okay, so now remember, the biggest thing here to recall is the idea that you don't want to include shifting or anything in your parent function. So the parent function of this, even though it looks really messy, the parent function is just that y equals log base 4 of x. Okay, so with that being our parent function, now let's rearrange it. So again, don't include any shifting. Don't include anything like that in your parent function, okay? Whittle it down to its most basic form. So in this case, this is the most basic form. And now 4 to the y equals x. All right, now you might notice that's actually exactly what we've already done, okay? We did that one just above, okay? So when you have that situation, and if it comes up in the homework, just copy down that same table, okay? You already did those calculations. So let's just copy down that very same table, okay? So we're going to use those same points. 1/2, or sorry, 1/4, 0, 4, 1. Now we have to take into account the shifting, okay? So how is it shifting? Well, this is sending it right 3. That is shifting it up 4. So this is where all of that shifting is going to now come into play, okay? Shifting it all around. So now I'm going to take every one of those points and I'm going to shift it. So I'm going to take this point right here, that point right there, right 3, up 4. 1, 2, 3, 4. And now that point lands right there. Let's take this point, right 3, 1, 2, 3, up 4. 1, 2, 3, 4. Let's take this point, right 3, up 4. 1, 2, 3, 4. So there are my new points. So remember how to just simply shift the points around, okay? That's what all those pluses and minuses right there are doing. The x minus 3 and the plus 4, just shifting it around. However, do note, that's not the only thing that's going to shift, okay? Notice all of my points shifted 3 to the right, okay? So that asymptote is also going to shift 3 to the right. So it's going to be sitting right here now. So don't forget to move that asymptote with the shifting of your graph if there's a horizontal translation. So in this case, it is this that's shifting your asymptote, okay? Now, once you have the asymptote drawn, now I can finally finish off my graph. Just like that. Okay, and its range, the range being really nice, being the all real numbers. And now the domain, well, this time I'm comparing it to 3. Okay, and where is it compared to the 3? Well, all those x values are going to be strictly greater than 3. All right, so let's keep moving. Well, what about when we have a situation like this? Okay, now we have a vertical stretch. Okay, now when you're rewriting the parent function, okay, when you're doing that, remember this is your parent function, the most basic form. So don't include anything in that parent function when you go to flip it around. So 2 to the y equals x, okay, which is what I got right here. So when you take the step to rewrite it as an exponential equation, ignore everything else about it, okay? So ignore that all. So we're dealing with 2 to the y equals x. So now we have the same situation, okay? Now what we need to do is pick y values to calculate the x values. So this x is really 2 to the y right now. So 2 to the negative 1 gives me 0.5. 2 to the 0, anything to the 0 gives me 1. 2 to the first gives me 2. 2 to the second gives me 4. In this case, 3 would even fit. 2 to the third gives me 8. All right. Now we have to take into account the fact that we had that stretch, okay? That vertical stretch of 5. So remember, we take that second column, and I'm going to multiply every one of those numbers by 5. So I have -5, 0, 5, 10, 15. Then I don't need that middle column anymore, okay? So recall, that's how you handle any stretching in this case. And now I have those points to plot, all right? So 0.5, -5, 1, 0, still the same, then 2, 5, and 4, 10. And then obviously this last one is off my graph, so it just stays as is. There was no movement. So because there's no movement, my asymptote is still here. Okay, my asymptote is still sitting there, and now I can connect my points. And it's going to trail off forever, getting closer to that asymptote. All right, my range is going to be all real numbers. Remember, we could pick any y to calculate the x, and for the domain, we compare the x to the asymptote. And in this case, it's everything greater than it. All right, so let's do one last graph, and then you'll be good to go. All right, so let's take a look at this, shall we? So remember, the most basic form, the parent function of this, is simply log base 5 of x, okay? Ignore the number out front, ignore the +1, okay? That is the parent function, the most basic form of this function. Ignore everything else, and now rewrite it. 5 to the y equals x. So that is what I'm going to be creating this based off of. Okay, so this x right here is really 5 to the y. So I pick my y values, which are pretty consistent to pick. Okay, if you pick those 4, you're always going to be in good shape. 5 to the -1, so 1/5 is 0.2. 5 to the 0, anything to the 0 power is 1. 5 to the 1, anything to the first power is itself. 5 squared, now we're getting really big. All right, and now this time we also have this negative out here. So I'm going to take every one of those values and I'm going to multiply it by -1. So 1, 0, -1, -2, and now I don't need that column anymore. So remember, that's always what you do for x-axis reflections or stretches. You do that. You multiply the y's Now, let's plot those points. So, point 2, 1 puts me about there. 1, 0 didn't change. 5, -1. 1, 2, 3, 4, 5, -1 puts me right there. And that 25 is way off the chart. All right, one last thing for this one. You have to remember to shift everything left 1. Okay, so every one of these points is going to shift to the left 1. And remember, that is also responsible for shifting my asymptote left 1. The asymptote shifts with the x's. And now, of course, I need to draw my graph. I need to connect the points. Well, this time, because of the x-axis reflection, notice this time it's approaching the asymptote, but it's approaching it upward, okay? So make sure you can see the curvature of it based on the negative or not, or based on following the points. So it can follow the asymptote up or down, simply depending on which way it's pointing. The range is always all real numbers, okay, because we're picking any y to calculate x. The domain, you always compare to the asymptote, and all of the x values are to the right, so that makes them greater than that -1. All right, so long notes of graphing, okay? But thank you for hanging in there. So if you flip the page, that's where your summary is going to be. So I want you to think about these couple of things. I gave you some hints on what you can consider. When does a vertical asymptote move? What is the range, always? And what changes the domain? So I want you to consider those things for me as you're thinking about the summary and reflecting on this lesson. Come back ready tomorrow to do your practice work.